Hello and welcome everyone. Thank you for joining us today for our webinar titled Introduction to Sparkling Water, Productionalizing H2O Models with Apache Spark. My name is Patrick Moran and I'm on the marketing team here at H2O.ai. I'd love to start by introducing our speaker. Edgar Orendine is a software engineer at H2O.ai. He studied computer science at UC Berkeley. And before joining H2O, Edgar was a lead software engineer building high-performance microservices in Scala. He engineered data pipelines at Hortonworks and was the architect of the company's new generation of data platform environments for the desktop. Before I hand it over to Edgar, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the questions tab. We'll be happy to answer them towards the end of the webinar. And this webinar is being recorded. A copy of the webinar recording and slide deck will be made available after the presentation is over. Now, without further ado, I'd love to hand it over to Edgar.
Awesome. All right. Thank you, Patrick. Again, this talk is going to be about productionizing H2O models with Apache Spark. An outline of what we'll be going over is we'll talk a bit about Apache Spark, and this will just be a quick overview. Now, for the sake of this webinar and just to be able to speed through, because there are a lot of really great things to talk on, to touch, we are going to assume some level, not necessarily technical expertise, but some general knowledge of what Apache Spark is used for and under what circumstances it's appropriate to use. Then we'll look at the basic machine learning workflow and talk about the H2O machine learning platform. Finally, we'll talk about the crux of this talk, sparkling water, which is sort of this marriage between Spark and H2O functionality. And finally, we'll wrap up with a few demos and use cases. And so this will actually be hands-on, and we'll look at some code and we'll actually see things run. And we'll go over some really common use cases. I'd argue the most typical use cases in the industry that we're seeing. So a bit about Apache Spark. It's an analytics engine for data processing. When you execute workflows, you do so in a distributed fashion to a number of different nodes. A lot of people use Apache Spark because of its powerful data munging and general data manipulation features. It comes with a number of different libraries which enable data manipulation and transformation. And as a result, you're able to use Spark to build machine learning pipelines. And not just machine learning pipelines, but also general data transformation and computational pipelines. It comes with a machine learning library, Spark ML, and it's used in tons of organizations, both small and large. So let's take a look at the basic machine learning workflow. Now this is a very high-level overview, and I am making some generalizations about the different stages just for the sake of simplicity. So the machine learning workflow starts with data engineering on the top left. Now, data engineering consists of ingesting data, exploratory data analysis, and data munging, cleaning, just generally data prep. Once you have your data prepped, the next stage over to the right is feature engineering. Now, I won't talk too much about what feature engineering is, but suffice it to say, feature engineering requires yet more data manipulation and transformation. Once that stage is done, we feed the data set, the data that we've transformed, into a training algorithm. So we'll apply, one machine learning algorithm or a number of them in order to produce a model, a machine learning model. And it's that model that actually performs the predictions, that we want. So that's the general, very basic machine learning workflow, but that's really only how you train a model. You train or create a model. Down below, you'll see that we have a very similar set of stages. And those sets of stages represent how we deploy a model into production. So not only are we looking to train a model, but we take this model and we've got to drop it into production somewhere. Now we just talked about Apache Spark and why it's so great and how many people are using it and in their organizations. And of course this talk is on Apache Spark. So we are going to assume, I think it's safe to reason that the production environment is Apache Spark. And by extension, we're going to say that the data that is ingested, the data that comes in for the data engineering stage, is also done in Spark. Again, this, there are a lot of different environments, but here we're assuming that we have a Spark environment for production. So what that leaves is the stage on the top where we don't necessarily need to use Spark. We could do this in Spark, but maybe you have a data scientist that is in love with scikit-learn or TensorFlow or the H2O machine learning platform. This doesn't necessarily need to be done in Spark, but you do need to make some considerations about how the work that you do on the top affects how you drop it into your production pipeline down below, especially because you actually have some of the artifacts, the feature engineering artifacts and the model artifacts that you want to just be able to create and drop into that pipeline. And so there needs to be some synergy or just general compatibility between what your data scientists use and what your DevOps team actually uses in production. So before we talk more about that, let's jump over and talk about the H2O machine learning platform. So it's an open source in-memory machine learning platform. It's built from the ground up to be fully distributed and parallelized. Now the reason that's important, that it's built from the ground up to be fully distributed, is a lot of machine learning libraries, say like scikit-learn. By default, they're not, they don't perform their workflows in a distributed fashion, and in order to do so, you have to leverage a number of other tools. And even when you embed, say scikit-learn into an environment where you can parallelize your work, the library wasn't built to be fully distributed or parallelized, and so it doesn't take full advantage of that environment. Whereas the H2O platform was built from the ground up for exactly this reason. It comes with your typical and advanced algorithms, for statistical analysis or clustering, dimension reduction, your typical algorithms like GLM, GBM, deep neural nets, a whole toolkit of ensembles. We're talking distributed trees, random forests, etc. And one of the most powerful sort of, some of the feedback about the most powerful sort of focuses of the platform is that it targets both speed and accuracy. Now, I won't share benchmarks just because you probably wouldn't believe me and you shouldn't take my word for it anyway. But at the end of the presentation, I have some links on benchmarks, and you can definitely just open up a browser and type, machine learning library benchmarks, and you can see how H2O performs against the more common or against the other popular machine learning libraries. Although, spoiler alert, the platform performs incredibly well. Another great thing about the platform is that it comes with a lot more parameters for precise control of the algorithms over other algorithms or other libraries. So if a library maybe typically exposes 2 to 3 parameters, the H2O library might expose 8 or 9. And you can use the platform via a number of different interfaces, Python, R, JVM, APIs, and it also comes with a graphical environment, which if we have time, I'll demo at the end. But what that means is it also has a very good entry point for people that aren't necessarily data scientists or aren't very comfortable with code and really want to do more of like drag and drop and click, but still want to build very powerful production grade, enterprise ready models. And so, the H2O platform sort of targets this from multiple vectors. So, we talked about this pipeline, right, or like this workflow, right, building these pipelines where whatever we decide to do during the training stages, whatever machine learning library we use to build a model, it needs to be able to produce this artifact, this model that we can just drop into a Spark environment and just have these work. Now, that's probably one of my most favorite features about the H2O platform, is this abstraction that it calls a MOJO. And what a MOJO is it's this packaged, bundled model with everything you need in order to enable production-grade deployments. And something really fantastic about this is that it's a single line of code. You export the model as a MOJO, and suddenly you have these production-grade deployments straight out of the box. There's no funny business, and there's no setting up. By using the platform, you've got something that you can drop in your production environment, and it just works. So a lot of people, I don't know if maybe some of you come from the world of plain old Java objects or POJOs, and MOJOs have a number of benefits over POJOs. And you can see some of them on this slide. Now, one of the most important ones, I think, is that MOJOs have no runtime dependency on the framework. So what that means is, once you're done building this model, once your data scientist has leveraged this really powerful H2O machine learning platform to develop, to train their models, and everything is fantastic, and then they pass it off to their DevOps team. Their DevOps team doesn't need to worry about bringing up an instance of the library of the platform in order to have this model in production. Everything is bundled in this MOJO, which is fantastic because you can drop it into any Java environment, Hadoop, Android, NiFi, really anywhere, any JVM environment. You just drop this MOJO and it's ready to go. And that I think is fantastic and definitely understated. So let's go back to the workflow. So the model that you see, don't know if my mouse is visible, but we've got this model that we build during the training stage, and because we can leverage H2O, we build this MOJO and we just drop it into the Spark pipeline, and things should work. But generally there's if we weren't talking about the H2O platform, there's generally a lot of considerations to make, like which machine learning library do you use? If you use a library that you typically can't use, with JVM interface languages, and you're sort of, you're for sure going to be deploying to Spark, and your data is being ingested through Spark, and you have to make some considerations like, well, how easy is it to convert from a Spark data frame to whatever type of data frame your machine learning library expects? How do you train an algorithm and then build a model to make sure that it's compatible with the Spark pipelines that your DevOps team uses? What if you want to do feature engineering or more data munging as part of this model pipeline building, where you want to go between Spark and your ML library? Is it do you have this interoperability? And a lot of people have been so fed up with trying to get those to work with their favorite ML library that they decide, I'm just going to use Spark for everything. If I have to use Spark for production and for ingestion, I'm just going to use Spark for feature engineering and for training. And so they just have Spark end to end. And so a few years ago, before Sparkling Water, people would try to, they'd have to decide whether they want to, harness the power of this Spark framework, but not go with a very high performant, or their favorite machine learning library, or if they wanted to stick with, very high performing and accurate machine learning platform, then how do they, do they have to build a deployment environment from scratch? How do they support that? And so one of the challenges was, that people were facing was, do you stick with Apache Spark, or do you stick with the H2O machine learning library and have to, sort of rebuild or build the deployment environment from scratch. And so the solution was this sort of glue between Spark and H2O, and called Sparkling Water, naturally. And so Sparkling Water allows you to have the best of breed everything. So you can keep your Spark environment. You build H2O models transparently using the Spark API. You can use the H2O data structures with Spark fully integrated. You have low latency inferencing that you get from the H2O platform, but all the while being assured that this works 100% with your Spark environment, that you can train a model with the H2O platform, drop it into your Spark production pipeline, and things just work. And you can go back and forth between a Spark data frame and an H2O data frame, without a hit to performance or latency. Now, I will fire up a couple of demos and go over a few use cases. The first use case we'll go over is probably one of the most common that you'll see when folks are using Spark and the H2O machine learning platform. And that is that your data scientist builds a model in isolation. And what that means is, you have a data scientist and she doesn't have to worry about using the same environment that DevOps uses. So she has the freedom to build a model using the H2O platform, and she just exports this artifact that she then hands off to the DevOps team, and they worry about deploying that via Spark. Now again, with the H2O machine learning platform, it really is just as easy as the data scientist running this one line of code saying, export the model, download the model, and then the DevOps team, we'll see exactly how easy it is for the DevOps team to just take this model and drop it into the Spark production environment. And so this graphic sort of goes over what at a high level that looks like. So here we have the modeling phase. This is the data scientist using the H2O platform. And then when it's dropped in a production environment, it's sort of dropped in the middle of this Spark workflow, where you have data source that gets you have a data source and the data gets ingested into Spark. Some data munging is performed, and then we have to leverage this H2O model. And then after a prediction is made, maybe we do some more work with the H2O library, or maybe we do some more processing directly in Spark. So let's take a look at that. Hang tight while I open up the notebook. All right. So this is going to be a two-part notebook. So the first part is the data scientist part. And so this was adapted from Franklin Velasquez's tutorial, and there's a link where you can find it, or you can bug him. He's got a lot of great tutorials and a lot of great info on how to use the H2O platform. So we'll walk through this. So we have some imports, and we're going to create an H2O context. So if you're familiar with Spark and Spark context, an H2O context is exactly the same as a Spark context, only it's used for the H2O cluster. We are going to import the data set with using the H2O library. And the reason this is really cool, and this is a feature that a lot of people like, is this import file method. You drop in, a file, a URI, whether that's on the, on your local disk or in the cloud, whether it's on GCP or S3 or wherever, and H2O knows how to handle it. It knows how to fetch it. It knows how to parse it. It knows, makes it has same defaults as far as how to process the file that you're giving it. Whereas we'll see later, if you were to do this directly with Spark, there are a few other options that you actually need to explicitly set. So we're going to import the data set from S3. We're going to split the data set. We're going to select the response column, and so this data set is a Freddie Mac loan related, sort of loan data set. And so the response column, it's not very important, but the response column is going to be delinquent. Now, here is where, up until now, this is sort of basic stuff, right? We've used the H2O library. This is pretty standard. It's part of the H2O library as well. And here we're going to build a model using the H2O library. We're going to use the AutoML algorithm. Now, I'm not going to run it only because it takes 5 minutes, and I just ran it before this demo. But I assure you it works. And so once the model is built, we can print out the leaderboard and see what H2O suggests are the top performing models for this data set. And then I'll rerun that. And then just as a to show that it actually works, we can predict. We can run some predictions against that model. And finally, we can export that production grade MOJO that H2O provides. And again, this is one line of code. And by downloading this MOJO, we've got this artifact that now exists here, which I will copy because we'll use it in the next notebook. And so we're going to be able to take this artifact and just drop it into a Spark pipeline. And so, notice that we didn't really use Spark here. This is just all H2O. Again, this is sort of the use case of the data scientist having freedom to use her favorite, her favorite H2O algorithms without being stuck using requirements that maybe the DevOps team sets. All right, so she creates this MOJO and she hands it off to the DevOps team. So let me copy in that artifact that we just created. So this is what a DevOps team or someone in DevOps might see. And again, this is a super simple example just for the for the sake of getting a taste of the features of sparkling water. So we're going to load in the exported H2O MOJO, and again, this is the artifact that we just built. This is the H2O model, and we're going to read in some data set as a Spark data frame. And again, right after that, this first command, we are now in Spark world. So everything here is, what you would expect when you're working just with the Spark API. You don't have to worry about, looking at the different APIs or docs for H2O. If you're familiar with Spark, then you're right at home. So we're going to read in this Spark data frame and using the model, using the H2O model, just like we'd do if this was a Spark model, we'd run some predictions on it. And just to show that it works, here are the predictions that were made. And so, again, what we're seeing here is that by using sparkling water, this package up here, for Python, we're able to take a model that was created using the H2O platform and seamlessly drop it in so that you can use it in a Spark environment. There's no sort of setup. There's nothing weird going on under the hood. It really is as easy as taking this generated MOJO and dropping it into your pipeline. And so that's the power that sparkling water provides. So back to the presentation, we'll look at the second use case. Actually, let me skip this. We'll maybe come back to this one just because I think this one's a bit more heavy. We'll jump to use case number 3. So this use case is when you have a data engineer that maybe builds a Spark pipeline, and then I won't talk about what a Spark pipeline is or much about the pipeline API, but if you're familiar with the pipeline API, then you know that Spark lets you sort of ensemble these different stages and transformations in order to build this end-to-end topography of work to do, and use the pipeline API for that. And a data engineer might be right at home using the Spark pipeline API, and they want to use the H2O algorithms as part of these different stages of this pipeline without having to first build an H2O model and then export it and then drop it in. You know, they might want to use an H2O algorithm directly in their pipeline. Now, you know, typically if you didn't have sparkling water or the H2O platform, one problem you'd have is how do you leverage this machine learning library, but then ensure that when you run this in production, you're not dependent on the platform in which the model was trained. And so we're going to see how using sparkling water, we don't have this concern. And this maybe isn't the best graphic to use, but if you imagine, yeah, maybe this isn't the best, this might be confusing, so I won't linger on this graphic too much. Oops. So let's take a look at that use case. All right. So again, this is going to be a two-parter. The first part, and this could just as easily be a one-parter, but just to sort of show that there is no dependency on the H2O platform when this is in production, we'll split this up into two parts. So we're going to have some imports. We're going to get our H2O context. Now, as a Spark data frame, again, we're going to try to do this as, you know, in as pure a Spark API as possible to see that we can, in fact, leverage the H2O platform from Spark. So we read in the Spark data frame, and we create this H2O pipeline stage. This pipeline stage is going to be leveraging the GBM algorithm, and so that's, you know, just creating the pipeline stage. Now we're going to create a Spark pipeline with just one stage for simplicity, and that one stage is going to be this H2O pipeline stage that trains a GBM model. And then we're going to fit that pipeline on some data, effectively training, you know, creating a trained or fitted pipeline, a trained model. We'll wait for that to finish. And then once that's done, we're going to save the sparkling water pipeline. Now, what we'll see, oh, that was fast. All right, so what we see here is that we create a Spark pipeline, and the Spark pipeline consists of this H2O stage. And so, you know, now we have this Spark pipeline that, you know, if you're familiar with, you know, you can just export. And so we've got the Spark pipeline. So let me open up this next notebook. We'll load in some imports. And now we're going to go ahead and load in this model that we just exported. And again, this, for all intents and purposes, is just a regular Spark pipeline. No funny business. There's no sort of, you know, weird connection that we have to make to the H2O cluster. We are just loading in a Spark pipeline as you normally would, again, if you're familiar with the pipeline API. We are going to read in a data set using as a Spark data frame. And just, again, to show that this works, and to show that it works without a dependency on the H2O cluster, so without a dependency on the machine learning library that we use, in particular that GBM algorithm. To show that we don't need a dependency on that, we're going to perform predictions using this pipeline. And we see that we do, in fact, perform the prediction. And again, this is, you know, what you see when you're working in Spark, only now you're leveraging the power of the H2O platform without actually having the H2O platform as a dependency, which I think is pretty great. Back to the presentation. All right, so let me hop back to use case number 2, which is also one of the most common approaches to having interoperable use of Spark and the H2O platform. So consider that you have a data scientist or engineer, because now we're sort of mixing things up, and they use both the H2O, they want to use both the H2O platform and the Spark APIs in an interoperable manner. And so maybe that means, you can see from the graphic here, maybe that means ingesting data as an H2O frame and, running some sort of transformation using the H2O library, and then, passing it back to Spark and running some Spark transformation, maybe doing some more, transformation using an algorithm that, only the H2O library has, that Spark doesn't have, and then maybe there's something in Spark that you really want to leverage that the H2O platform doesn't have, and so you want to do, you want to leverage that. And then finally, you want to pass it off to the H2O platform for training a model off of. So we're going to see how easy it is to go from H2O data frame to a Spark data frame without any sort of hullabaloo, right? Like if you were to try to have interoperability between Spark and, again, scikit-learn, you'd know that there are a number of steps that you need to make if you want this to run in a distributed fashion, namely leverage the joblib toolkit and then connect the joblib, set up a Spark backend for joblib, and then make sure that's connected to your Spark cluster. There's a number of different steps to make, but we're going to see how easy it is with the use of Sparkling Water to just connect H2O, ML, and Spark. Oops. So let me bring up that use case. And this, I think, is going to be a single notebook, if I remember how I wrote it. Yes. All right, cool. So we're going to import H2O and Sparkling Water. Again, we do have interfaces, not just for APIs, not just for Python, but also R and Scala and Java, of course, anything that runs on the JVM. We're going to get an H2O context from our Spark context. We're going to import a data set using H2O. So this is reading data in as an H2O data frame. Now let's use some of the H2O APIs to maybe do some EDA, right? Some exploratory data analysis. Let's say we want to look at the distribution of the different values in the delinquent column. We can do that. If we want to look at the histogram, or the distribution of another column, we can there's a method to do that quite easily, including to render visualization of using the H2O library. And you'll notice that we don't have any other imports like matplotlib or anything. This is native to the H2O library. Now let's say we want to convert a Spark data frame an H2O data frame to a Spark data frame explicitly, right? And instead of doing this implicitly, just for the sake of this demo, we want to see how easy it is if we actually want to do this explicitly. It is one line of code, and you will see that completed pretty quickly. The reason that is because when you convert between a Spark frame and an H2O frame, you're not actually duplicating any data. You're not duplicating any data. Really, there's this facade that gets exposed, so you can run Spark data frame operations on top of H2O. Let me zoom in a tiny bit. All right, so we do that. Let's say we want to run some Spark operation. We want to see how many distinct product types there are. Whoops, yeah, there we go. We want to see how many distinct product types there are. There's one, so that means we can drop the product type column because there's only one product type for the entire data set. So we're going to drop that as a Spark operation. And now we're going to go ahead and, for some reason, we decided we're going to convert the Spark data frame to an H2O data frame, and we do that. And then this last part I'm going to leave out just because, again, so it maybe take a little while to run depending on the parameters that we set. But now that we have an H2O data frame, we can pass this data off to the H2O cluster to train a model off of. And again, that takes us back to the first use case where now having used both H2O and Spark for data manipulation, just data munging and maybe feature engineering, we've produced this this model, this artifact that now again we can drop into any environment, including our Spark environment, quite easily. So that's use case number 2. I do have a few extra slides, but I know we covered quite a bit, so maybe it'd be a good idea to get a couple questions in, and then depending on time, I can go through a couple extra slides that I prepared. So before we take Q&A, here are links to, well, on the bottom we'll have links to benchmarks. Definitely check those out. I think you'll be pretty impressed. We've seen a lot of companies move to the H2O platform for the reasons that you'll see here. There's documentation and tutorial, and if you want a free cloud environment to check out the H2O platform without spinning up your own and getting charged, check out aquarium.h2o.ai, where you can spin up a free cloud environment and actually go through step-by-step some tutorials and sort of leverage these tools on your own.
Great, thank you, Edgar. So let's open it up for questions. Please feel free to start sending those in. In the meantime, I am seeing 1 or 2 that have already come in. First question is, I've tried calling to pandas on the Spark data frame, but it takes a very long time to complete and uses a lot of memory. Does this happen with H2O and sparkling water?
Okay, very good question. So this is sort of a 2-parter. So I'll explain why if you use, if you're already using Spark and you call 2 pandas on a Spark data frame, it may very well take a really long time to complete. And as the question suggests, it does take a lot of memory. So I'll explain why that is underneath the hood when you're using Spark. So underneath the hood, because Spark is distributes the data frame across a number of different nodes, when you call 2 pandas needs to aggregate all the data into a single node, particularly your driver node, your local node. So what's actually happening underneath the hood is all the data, all the different data frames on your distributed Spark environment are being moved over to your single node, to your local node, and then there it's being rebuilt into a single data frame. So there is data duplication. Now, this does not happen when you use H2O and sparkling water. The reason that is when you convert between an H2O, so an H2O frame is distributed in just the same way that a Spark data frame is. And when you convert from a Spark data frame to, from an H2O data frame to a Spark data frame, there is no data duplication. Again, what's happening is that there's this facade, being wrapped around the H2O data frame that allows pass-through Spark operations on it. So going from, again, an H2O data frame to a Spark data frame, there is no data duplication. You won't see a spike in memory. It is seamless. Now, if you go the other way around from an H2O data frame to a Spark data frame, there's a tiny bit of more work because the Spark data frame needs to be compressed into the H2O data frame format, but it is super compressed and doesn't actually take much memory. Yeah, great question.
Great. So that's actually it for now. I think we can probably continue on to those additional slides that you had, Edgar. And folks, please feel free to start dropping those questions in, and we'll save some time after these next few slides to go over the rest of the questions.
Yeah, all right, excellent. So, so if we got a couple minutes, here's the slide at, again, a very high level of what the sparkling water architecture looks like. If you're familiar with Spark, then a lot of this will look very familiar. Now, the H2O nodes are, when you're using Spark, the H2O nodes are started on the Spark nodes, directly on the Spark nodes, which means that when you execute your H2O code, it's really executing directly in the Spark executor. And now what this means, and also I'll sort of say it explicitly, is that H2O and Spark share this same memory space. So you can freely transfer between Spark and H2O without any overhead, which again isn't the case if you're using other machine learning platforms. And again, this actually wasn't the case before Sparkling Water. If you wanted to go from H2O to Spark, you had all these troubles that Spark and then the other machine learning library introduces. But at some point, so many, or a lot of organizations wanted this interoperability between H2O and Spark that Sparkling Water actually came into inception. And so so Sparkling Water is driven by these enterprise grade use cases, and the architecture is driven by what would be generally considered best performing, or quote unquote most useful for DevOps teams in their environments. So I would kind of go back to let me go back to this notebook here. There's this let me go back to this notebook. One of the things I sort of skipped over,
Yeah, we've, so I just saw a couple questions come in. Does Sparkling Water provide APIs for feature engineering? Do you do it yourself with the Spark framework?
Okay, yeah, great question. So, so feature engineering is sort of there's a lot to feature engineering, right? Feature engineering sort of entails, can encompass a number of different transformations, and is sort of, sometimes it's conceptually bundled in with data munging. So now feature engineering isn't explicitly part of the H2O platform, but depending on what kind of feature engineering, well, actually, let me sort of give you the simple answer first. Yes, the H2O library does in fact have algorithms for performing, for readying data for feature engineering, for doing feature engineering. Yes, though in practice, because feature engineering is sort of heavy, you might want to use both APIs from Spark and the APIs from the H2O library. For example, one of the things that the H2O library is missing that Spark provides are algorithms for NLP, natural language processing. And so when you're doing NLP, you'll, with H2O, you'll find yourself doing some feature engineering and data munging with, maybe like word to vec or, whatnot with H2O, and then maybe using Spark to run some other NLP algorithms. So yes, you absolutely can use the H2O platform for it, and there are libraries for Spark to do it. In practice, it's sort of hard to say because it really depends on use cases, and not all libraries have, not any one library will have what you need. So sometimes you need both, Spark and H2O, which is where one of the use cases comes in.
Great. Next question. Although the webinar was focused on deployment, could you elaborate on H2O's AutoML? Could you talk a bit about how you trained the models in your first demo?
Oh, okay. That's what a coincidence, because that's actually the notebook that we're in. So the model that we trained in this first notebook is here. I was actually going to talk about something that came a bit after that, but this might be a good starting point. So we're using the H2O AutoML algorithm to train our model. Now, if you've trained models, you might be, maybe you're used to calling, a linear regression algorithm, or GBM or XGBoost directly, but here you see, GLM, GBM, and XGBoost, and even some ensembles. But we somehow managed to get that from this call to H2O AutoML. Now, for those of you that might not be familiar with AutoML, AutoML is automatic machine learning, And it is available with the H2O, H2O platform. Now, what the in fact, I do have a slide actually. This is perfect. Now, what the AutoML algorithm does, in a nutshell, before we maybe go into a bit more detail, is it automatically performs. It automatically applies a number of different training algorithms and creates this leaderboard of the top performing models that it's tried to create. And so as part of the algorithm, the AutoML algorithm, there is some basic data pre-processing that's going on, and this happens in all algorithms. The algorithm trains a random grid of GBMs, deep neural nets, GLMs, with in a particularly chosen hyperparameter space, and that you can actually tweak. And then you can either set your own validation, or AutoML will perform its own cross-validation by default. And after it finds the best performing models, and I sort of say best in quotes because you can tell AutoML to run for a particular amount of time. So you can tell it to only run for 5 minutes, which is what we did, and it'll find the best model it can in 5 minutes. Or you can tell it to train 10 models of each kind, of 10 GBMs, 10 DNNs, 10 GLMs, and it'll take however long it needs to, for it to train those models. Afterwards, it creates stacked ensembles, and then returns the leaderboard of all the models. And so that is actually what we see here. So you run AutoML, and you, as part of that one call, you get all of these different models, and they are sorted by the best performing. And best performing here is defined by the AUC metric. And so here we see that that there's an XGBoost model that performed the best. Again, this is and this is kind of impressive considering AutoML only ran this algorithm only ran for 5 minutes. So there's a lot more to AutoML, and again, AutoML is being implemented by a number of different ML libraries, including H2O. Now, I won't speak to its to how well it performs, but definitely check it out. And this presentation does have a link to those benchmarks. But again, spoiler alert, you'll see that the AutoML from H2O performs really, really well. And so I hope that was sort of a good intro to what that is.
Great. Next question, can you run Sparkling Water from the Spark shell?
Yeah, definitely. You can run it from the Spark shell. You can run it from like a Python REPL. You can run it quite seamlessly in scripts like we do here. We sort of run this in a Jupyter notebook. There are, in fact, let me just bring up H2O download. Let me bring up the download page. Oops. So I won't go into detail, but there are a ton of ways to use Sparkling Water. There's a ton of documentation to check out. The sort of the more popular ones are running Sparkling Water, on Hadoop, on standalone. You can use it there. You can import the dependency in Maven if you're creating an app. You can use the R API, the Python API, and here you can run it using. This shows how you can bring up a PySparkling or Python shell, and I think do we have yes, here we go. And so I think this is what the question was: how do we run it with a Sparkling shell? And so there's some info here. Again, lots of documentation, but the short answer is yes. And definitely check out this page and the docs for more info on how to do that.
Okay. This is about Mojos in particular. Can the Mojos be directly deployed into apps and dashboards?
Okay, yeah, great question. So this is sort of a two-parter. So apps and then dashboards. So apps is sort of the easy one, and that is 100% yes. In fact, that is what we see a lot of companies use Mojos in. And you know, without naming companies, you could just do a search and you'll see there are a lot of companies that prefer the H2O platform because you can export this Mojo and just drop it into any environment. So we see Mojos used, again, they're really powerful in Spark environments, and so people drop it into, you know, their Spark pipelines. We see people drop it into Hadoop clusters that may not be running Spark, and sort of just, and you know, wrap it in a very lightweight Scala or, you know, Java, or, you know, generally JVM wrapper. Yeah, I mean, really anywhere that you have a Java environment, you can drop this in. So as far as apps go, absolutely. And even if it is, you know, if you're not running this in a Java environment, there are still ways to. We do have drivers to run this in, you know, say C++ or R, you know, Python or whatnot. And there's documentation on that. For dashboards, I'm not sure. That's a really good question. If people use Mojos and dashboards, and I haven't personally seen that, so I can't say for sure. So I'm not sure, and maybe I could definitely ask around and get back to that the person that asked that question. But that is a good question, and I don't know.
Great. Okay. So that was actually the last question that we have here. If folks want to take one final try and get some more questions in, we do have a few more minutes left in the presentation. But in the meantime, just want to give everybody a reminder that the presentation is being recorded and slides will be made available after the webinar is over. So there's plenty to go through here. All the links that Edgar has shown will be made available to you so that you can peruse them on your own time. But yeah, let's give folks another 30 seconds or so to get some questions in, and if not, we can just go ahead and wrap up, giving you some more time back to your day.
Yeah, and I will, so these slides I'll hand over to Patrick, and I'm sure he'll make them available. And if folks are interested, I'll also, you believe it or not, those notebooks I actually just whipped up last night. You know, and I wasn't worried about, you know, being on a time crunch, just because I know the APIs are really easy to use. And so there are more examples in the docs, but in case anyone's interested in using these sort of to bootstrap you know, maybe their learning journey with H2O or Sparkling Water or even Spark, I'm happy to export these Python notebooks and make them available to whoever needs them. You know, definitely open source. You know, not worried about closed source or keeping any secrets. You know, everything you see here is definitely for the community to leverage.
Excellent. Okay, well, I'm not seeing any further questions come in, so I want to say thank you to Edgar for taking the time today and doing a great presentation. And I'd like to thank everyone who joined us as well. Have a great rest of your day.
All right, thank you.